Hi everyone, Darren from Ireland. What's the difference between shielded and unshielded cables? In my previous video I went over differential mode and how it works to keep electromagnetic induction out of data cables to maximise performance. If you missed it, I'll include a link below. In this video I'm going to go into the different types of UTP cables and what else we can do beyond differential mode to keep EMI out and bandwidth up. So cables are rated by the frequency they support. For example, Cat5E cable is rated to 1 to 100 MHz, Cat6 1 to 250 MHz, Cat6A 500 MHz and so on. What that means is that they're designed to support that frequency for a full 100 meters. To manage that, they need to be constructed using certain gauges of wire, a certain quality of the materials that they're made of, twist rates, wire spacing, and adding screening and shielding. Does that mean that the bandwidth the cable is capable of is dependent on the transmission frequency it'll support? Not really. If we're only able to send 1 bit per wave cycle or hertz, then we would be limited by the transmission frequency. However, we can do a lot more with encoding the signals and manipulating the wave shape to send huge numbers of bits with each wave. But the transmission frequency rating of the cable is still a factor if we go back to what that means in the way the cable is constructed to support those higher frequencies. All of that twisting and shielding adds up to how it can deal with impeding factors like EMI, echo cancellation, equalization, DC balancing, near-end crosstalk, far-end crosstalk, alien crosstalk and so on. And that's how we get higher bandwidth. It's more the quality of the cable rather than the frequency it'll support. So a cable like Cat6A, which is designed to support a frequency of 500 MHz for 100 meters, we know to support that frequency, it's been made to a quality that will support 10 gigabits a second over 100 meters as well. So what happens if we ignore the frequency rating of the cable and just try transmitting higher frequencies or higher bandwidth than the cable was designed for anyway? Well, it still works, but we won't get the promised 100 meters distance out of it. If we put 500 MHz down Cat6 cable, for example, which is only rated at 250 MHz, we're usually only going to get 50 meters or so out of it. A quick plug for Dintex PowerMax 500 series Cat6 cable here, which we know exceeds that criteria, and we can get 500 MHz for 70 meters out of it. It tests highly in all other respects as well. If we step down even further and try to transmit 10 gigabits a second over Cat5E cable, we might only get 20 or 30 meters. Beyond that, the speed's going to drop off fairly quickly. If we try to transmit 1 gigabit per second over Cat5E, we'll get a little more, maybe 50 meters, which is what its standard specifies for gigabit. But if we only care about getting at least 100 megabits per second, we're going to get 100 meters out of it, no worries, assuming that impeding factors like crosstalk and EMI or anything else that can affect the signal to noise ratio isn't present. The take-home message is that if you want 10 gigabits a second over 100 meters, go for Cat6A cable, but if your cable runs are only 30 to 50 meters or so, you can probably get away with Cat6. If you're only looking for gigabit speeds, Cat5E will still do up to about 50 meters, but Cat6 will do it much better and right up to 100 meters under normal home or office conditions. These days for standard home or office cabling, I personally wouldn't settle for less than Cat6, and gigabit switches and other equipment are great bang for buck. But if you want to future-proof yourself a little, go for Cat6A or Cat7 and upgrade to 10 gigabits a second equipment down the track. You might have also heard of Cat7A and Cat8. Well, these are more for installation in data centers and corporate networks and so on, rather than for standard home or office cabling. They have quite stringent and grounding installation practices, and while they're promising 40 gigabits a second speeds, we're only talking fairly short distances of maybe 30 to 50 meters, or maybe even speeds up to 100 gigabits a second for maybe 10 or 15 meters. Don't forget, to get those speeds you also need signaling equipment, switches and network interface cards and so on that can also support it. But twisting the pairs isn't the only thing we can do to improve cable performance, which is particularly useful in environments with lots of radio frequency noise or running HDMI video over Ethernet, which tends to generate lots of crosstalk. This is where we get into adding screening and grounding to twisted pair cables, commonly called STP or shielded twisted pair, instead of UTP, unshielded twisted pair. The cabling industry uses code letters separated by a slash to identify shielded and unshielded cable types, and shielding can be applied around the outside of the cable or around the individual pairs inside, or both. Unshielded cable that most of us call UTP is actually U/UTP. The U before the slash indicates that the cable jacket is unshielded, and the U after the slash means that the pairs inside are also unshielded. TP just means twisted pair. If we see an F in the name, that indicates foil shielding, and an S indicates braiding, which works like a Faraday cage around the cable. So from that we can work out that if we see a cable marked as FUTP, it means that we have foil around the outside of the cable, indicated by the F before the slash, and the pairs inside are unshielded. UFTP is the other way around. an unshielded jacket, and foil around the individual pairs. SFTP means we have braiding around the outside of the cable, indicated by the S before the slash, and we have foil around the individual pairs inside, indicated by the F after the slash. So here's a U/UTP unshielded cable example. This is Dintec's PowerMax 500 Cat6 cable that I mentioned earlier, which is constructed using 23 gauge wires, which are thicker than usually found in Cat5e cable and a lot of Cat6 on the market as well. That larger wire gauge means less heat generation and voltage drop over long distances, which results in better and safer performance, particularly when we start getting into PoE or Power over Ethernet. The latest Type 3 and Type 4 PoE standards are starting to hit the market now, supporting power up to 100 watts. That's enough power for stuff like desktop computers and LED lights. LED lights I think is worth a mention. Why would we need PoE to power a light? Well, there's a new technology starting to come out now called Li-Fi, which uses light pulsing at much higher speeds than our eyes can detect to transfer data instead of Wi-Fi. And it's a lot faster than Wi-Fi as well. I'm anticipating the technology is going to take off very soon, and we're going to need cable for that, which will not only support PoE to power the LED bulbs, it'll also need to support high bandwidth to get the data to and from the bulbs. With the advancement in PoE technology, soon we're also probably going to see office workstations that don't even have a power point anymore. Sending 100 watts of power down cheap cable, especially in a bundle of cables, is asking for trouble. And this is Cat6A UTP. It looks very similar to Cat6 at first glance, but it's a noticeably thicker cable, mainly due to a larger plastic spacer inside to help shield each pair and create a bit of distance from the EMI that the other pairs generate. This is too thick to fit into an RJ45 plug, so we can't use it for patch leads. You'd mainly see this connected behind wall plates and patch panels. Dintec's PowerMax Plus Cat6A UTP is available either with a flame retardant PVC jacket or an LSZH cable jacket. Cat6A SFTP. The S before the slash means that we have an exterior braided screen around the whole cable. The F after the slash means that each pair is individually wrapped in foil. All that extra screening means that the twists don't need to be as tight, which makes it a bit thinner than Cat6 UTP. Dintec's PowerMax Plus Cat6A SFTP also supports up to 10 gigabits a second and is constructed using 23 AWG conductors, and it's also available with either a flame retardant PVC jacket or an LSZH cable jacket. The extra shielding in SFTP minimises alien crosstalk, provides excellent signal isolation and provides superior EMI protection. So it's the way to go in environments with lots of RF noise, electric motors, fluorescent lighting and power cabling, or for applications that generate lots of crosstalk like HDMI video. I'll link below to the full PowerMax Plus Cat6A range with detailed specs. Cat7 SFTP looks exactly the same inside and out as Cat6A SFTP, but there is a performance difference. That would come down to the twist rate in the cable as well as the quality of the copper used and so on. Cat7 and up is always a shielded foil wrap twisted pair cable due to the high frequencies that they're supposed to support. Cat7 supports up to 600 MHz compared to 500 MHz in Cat6A. Dintec's PowerMax 7 cable is available with either a flame retardant PVC jacket or an LSZH cable jacket. Again, I'll link in the description below to the full PowerMax 7 Cat7 range with detailed specs. So that's a little bit about shielded and unshielded twisted pair cables. If you enjoyed this video, please give it a like below, and don't forget to subscribe and give the little bell a click if you'd like a notification of any new videos as they go up. Please check out our webpage at www.dintec.com.au, and if you need any more information, please comment below or send us an email to sales@dintec.com.au. Thanks and bye for now.